Hello everyone. In this video, we're going to talk about how the scheduler of Toro behave in a multi-core system. And to show this, we're going to take the examples that we did last time, in which we have three threads and we schedule these three threads in a monocore system, where we're going to run the same example, but this time in a system with three cores. So let's just see the example we tried last time. So here, what we have is three threads executing the thread function, which is only printing the ID of the thread, and each thread is created with the ID different and also in the same core. So if we execute this, we got something like this, in which each thread is executed in the same or scheduled in the same order that has been created. Let's see what happened when we run this three thread but in a system with three cores. The first thing we're going to do is just to configure QEMU. So I'm going to tell QEMU to emulate three vCPUs or to create three vCPUs. Cool. Let's just try it to see if Toro find the cores. So we can see in the logs that the three cores are there. Next, we're going just to modify the example to create the threads in different cores. So to do this, we have first to change this parameter. The first thread we're going to create it in the core 0, the second one in core 1, and the third one in core 2. Cool. But in this time, I don't want to have a loop. I just want to see if each thread is created in the right core. So let's just comment this on this. And also I'm going to add some blocks here to see that the thread is in the right core. So I'm going to add something like this. And I'm going to get the ID of the current core. I think we're done. Let's just execute it. Okay, what we have here? Well, the three thread execute. The thread that corresponds with ID 0 execute in core 0, and the three with ID 1 execute in ID with ID 1, and so on. So what we're going to do now is to try to make this thread print something in the screen, but when this happened, they're going to compete over a lock that have to get in order to be able to print on the screen. The screen in ToroKernel is a resource that is shared by all the cores and the thread. And in order to print or use it, the thread has to get the spin lock. So let's try that and see how these three threads compete over the resource. To do that, we're going to keep the loop here. So what is going to happen is that the three threads are going to compete to get the spin lock in order to print on the screen. And let's see if this results in a fair scheduler. We can see already that it's only the thread in the core 0 that is going this that is getting the spin lock. And this is the reason why we only see this print. But now what we can see is that then there's the thread at core 1 that get it. And we can see that it's not fair in the sense that we're not seeing one after the other. And now we see that this is the core at thread 2 and then the 0 again. But it's not like that is one and the other. And the reason that we see this possible is because the way that vCPUs are implemented in Linux. These are normal threads in the hosts, that is the Linux scheduler that is going to say which is the next thread. So we don't have really um, parallels, real parallels in this case. I hope you have enjoyed this video, and feel free to visit the website to get the source code and try yourself.